اتفضلي يا دكتورة إيرا.
طيب احنا we are going live، بس هنستنى بس يعني دقيقة أو دقيقتين كده إن شاء الله الاتنديز كلهم يدخلوا وبعدين نبدأ. Welcome everyone to our webinar. We'll wait just 1 or 2 minutes to wait for all the attendees to enter, and then we will start directly the webinar. Okay, so actually this is the first time we do that, but before we start the real and the actual webinar, I'd love to ask you for one thing. I will launch a poll now. Just we want to know the percentage of people attending with us today, because we've seen people registering from who needs us to be giving the webinar in English and who needs it in Arabic. So just we'll give the poll a couple, maybe 1 minute, and we'll see the results. And accordingly, we'll do the language that the higher percentage has. Okay. Okay, so we've got, people are still responding. Dr. Tarol, it seems that we got a lot of natives here, so at least 30% so far are natives, need English language. So we'll decide whether we do the whole thing in English or we can repeat some parts of it, if you think that's okay for you, Doctor. For my part, it's a small part, so I can actually say it in both Arabic and English. So yeah, let's see. After the rest of the people just finish their poll. So it's almost 30 to 60, okay, and there's 12% other. Okay. Okay. A quick second thought, so that we just know, if you are a native and if you are your mother language is Arabic, will you be able to understand the webinar in English? If that's fine by you, just to know again, if we can continue in English, that would be great, so that we can just capture the whole list without having to repeat all the text twice. Okay. The percentages are increasing. Okay. Doctor, we have almost 85% who can understand the webinar in English. Only 15% who would like to have it in Arabic. So do we continue the rest in English, and then maybe we can just like do a very quick summary at the very end of each talk in Arabic, if that's okay by you? You are muted, dear Doctor.
Yeah, I'm okay with that. Okay.
I don't mind.
Okay. Okay, sure. So we'll do that. We'll continue the webinar in English. Only, actually, it's less than 15% who needs it in Arabic. So we'll continue in English, and then we can do a quick summary at the very end of each panelist in Arabic as well. Thank you for sharing your answers with us. So first of all, I'd like to welcome you all to our webinar. It's interesting to have all this number with us and to be waiting and talking to you about a very advanced topic. Actually, today we'll be having Dr. Talal with us to share his experience. But let me tell you first a quick thing. If you attended any of our previous webinars, you will know that it's not always about Praxilabs or showing you our platform and experiments. We also like to talk to you about the most advancing platforms, the most advancing approaches in EdTech, education technology in general. And to do that, we always like to get you experts from everywhere in the world to talk to you and share their experience. So today I'd like really to And I'm honored to have Dr. Talal with me. He's the Director of E-Learning and Distance Education Center at the University of Jeddah. And he will be talking to us about the Saudi Arabia's 2030 vision and how the e-learning is one of the key pillars there. Also, very important topic as well is giving us then best practice and talking to us about how the University of Jeddah has been leading and is really like acting as the launch pad for other universities to follow and their success in the different e-learning aspects, especially, of course, the virtual labs. And then you will hear from myself about the most important challenges. Some of you might know already if you're a professor. You might know, of course, the challenges that I will be talking about. So it will be very brief and tell you how Praxilabs is today helping universities, schools, and professors around the world in improving their students' learning outcomes and their retention as well. And finally, Dr. Hiba, our biology science director, she's with me in the webinar. She'll be giving you an amazing demo, as usual, demonstration on how Praxilabs is being used today in some of the most top faculties and universities in the UK, US, Saudi Arabia, Egypt, Philippines, and a lot of other countries. And yeah, so that's all from my side. Just I love that these are the key topics that we've been talking about that you learned from us in this webinar. And just quickly, you do not have to take any notes. Everything will be shared with you. The recording and everything will be shared. If you have any questions, please share them in the Q&A, and we'll be having a session at the very end of the webinar to answer all your questions. And we will also send you in the chat box now, if you want to create a free account just to try Praxilabs and see yourself, you'll definitely be able to do that if you create an account on the website. And you can also check all our list of portfolio and experiments as well. So I'll finish at this part. Dr. Please go ahead and share with us your experiences.
Thank you so much, Dr. Khadij. Hello, everyone. Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Dr. Talal Al-Asmari, the Director of E-Learning and Distance Education Center at University of Jeddah. First of all, I would like to thank you, Dr. Khadija, in person, and your team, Hiba, and the rest of the Praxilabs team for their support, not only today, but from the day one that we started thinking to collaborate with you and to bring more rich experience to our students since last year. First of all, let me tell you our story here in University of Jeddah. But before that, Dr. Khadija mentioned the 2030 vision, which is part of the ambition vision in Saudi Arabia. So the Crown Prince Mohammed bin Salman, in his last meeting about the vision in last Ramadan, he mentioned that there is a huge gap between skills and knowledge in the sector of education, either public or private education. And from his point, yes, I have experienced this myself and went through this myself last year in March when COVID-19 strike. So we started realizing that we were left behind, and we need to figure out a solution. First of all, in March, I believe in March 9th, 2020, we were asked to prepare academic continuity plan before we shut down or we closed the campus due to the COVID-19 issues. So what we have realized at that time, there is no solution for our students to attend their labs remotely. This is one of the gaps that was identified earlier in the COVID-19 lockdown. So I tried my best to meet with the professors at the University of Jeddah and talking to them what their solutions. Some of them asked me to record each single experiment, okay, and provide these experiments as video links to our students through the LMS. Other suggested to only send them the handouts and keep students informed about the knowledge part of the experiments without experiencing the actual experiments themselves. So at that moment, I started searching for other solutions. Praxilabs came to my mind when I browsed the available solutions in the region. And Praxilab had or still has two advantages in the region here. One is the Arabic language support for our learners who cannot fully understand English, especially in some topics and some remote areas in Saudi Arabia. The other part is the support that we receive them all the time. No time differences between Praxilab headquarters in Egypt and Saudi Arabia. So we can reach them at any time and we can get support from them at any time. This is from the administrative part. From the technical part or from the educational part, we had a demo with Praxilab. And one of the constraints that we experienced with the Praxilab is the limited number of experiments at early stages of the implementation of this project. We had 100 experiments in biology, physics, and chemistry, but Praxilab's team provide a very collaborative way or approach to work with us. So they ask us to provide them with a list of experiments that is requested or most requested by teachers and students to be added in the list of the available experiments. I already talked to my peers in the region of Saudi Arabia and asked them to prepare a mutual proposal to Praxilab to focus on the most used or the most requested experiments, both in biology or in chemistry, also in physics. So what Praxilab has brought to our students. Seriously, we couldn't catch up last year with the question with Praxilab until the middle of the last semester, I believe. So our students and teachers started realizing the functions and the features of Praxilabs. So we held two workshops, I believe, Dr. Khadija, one in Arabic, the other one is in English. And we provide them along with the Praxilabs with the required or the requested or the needed training. So some of them really were amazed. Some of them didn't expect a solution like this, either because of the some obstacles inside the university or outside the universities, but we were able to bridge some gaps in the lab requirements and experience for our students, especially in the early stages or in the early courses of science. 101 physics, 101 chemistry, and 101 biology. What I need to mention here is the adoption of the system or the acceptance of the system. Users usually tend to be distributed among or based on the adoption of any new systems as early adapters, and some of them as resistant factors or users for any changes. What we have done here is to use the early adapters of Praxilabs as a power of promoting the system among our teachers and students as well. One great feature of Praxilab is the integration with LMS. So we were able to integrate each single experience with our Blackboard, and I believe it's available with same thing available with any other LMSs like Moodle or Canvas. So you can add each single experiment inside your course or inside your folder, topic folder, and you can grade students based on their performance of the experiments. This may encourage students and teachers to adapt the system more effectively by adding the grading part to the use of the system. I don't know, Dr. Khadija, if you have any specific questions for me, or you, your participants here have specific questions for me. But overall, I mean, our stories with the Praxilab is still in the beginning, and we are growing together. Here, our students and our teachers, and also here at e-learning centers, we are learning from you guys at Praxilabs, and we are working with you to improve and bring more rich experience for our students in the upcoming year. So yes, go ahead.
Yeah, thank you so much. I'll keep the questions from the participants actually till the end. We usually do that, the last part of the webinar. So now I would like actually to ask you some of the most important questions we've been getting. Not now, I mean not in the attendee, but before that. When people talk to us from different parts in the world, we think that there is a bit of a difference between the challenges. So for example, in the West, maybe they don't have the same kind of problem, the cost. Maybe they already have labs and they have a lot of facilities, so it's not about the cost, but maybe it's about the safety of the students. They want the virtual labs because the students cannot, for example, do dangerous experiments like ones contain cancerous substances, etc. Or other universities might be only focusing on improving the students' learning outcomes. So in our region, in the MENA region, maybe it's a bit different for us. Do we focus more on the safety, or is it even from your side, as in Jeddah, did you use it for the safety or for the improving students' outcomes or for practicing a lot of times, as you said, like maybe they, because of the lockdown happening, but even after the lockdown, we'll still be using it. So what are the most important factors that you think from your perspective as University of Jeddah and Saudi Arabia would be for using the virtual labs?
Yeah, to be honest with you, at the beginning, I, as a person who is in charge of e-learning, I was only thinking of the academic continuity as a priority for me and for the university to run the labs safely in the time of lockdown. But we started to, leveling up our objectives with you guys. So we have 3 or 4 different branches in University of Jeddah. Some of them in the remote areas have a less access to labs, to the physical labs. And also, as you know, in the Saudi culture, there is a segregation between female campuses and male campuses, which may, give one gender advantage over the other gender. So this is a way of ensuring the equality in our education, especially in the part of the science and experiencing science from our students. The other part is also it's a quality or equality, or a way of ensuring the equality between the rural areas and the urban areas in providing the best educational experience and services that we can offer and provide at this time. So different objectives, and we were able to leveling up our objective as we go through the project, and we will measure these objectives as soon as we reach the milestones of the project implementation with you. What I need to bring to the attention is Praxilab and the virtual labs. The virtual lab is not like one-time solution or one-time system that we can bring and ask our student to use. No, it is the content development and the content creation and improvement is the most critical part of this. So that's why we started the negotiation with the Praxilab and their team to improve the content and to add extra experiments, and also to sometimes we provide them with handouts, the experiment handouts, so they can include some parts of the ideas in their system. ولذلك for that, I believe content development process or the procedure of content development in the virtual lab is not one time, or it's not it is a recontinuing or recycle the content all the time through the year, so we can ensure our students getting the best experience and the best knowledge that can support and improve their learning. From the part of improving learning and student performance, we haven't measured this this year, but Dr. Wissam is with us, who is in charge of this project at University of Jeddah with me. So we will plan for measuring the students' performance through virtual labs. By the way, I'm talking to you about the virtual labs, not only Praxilabs. I have another solution for the medical students, and I have another solution for the applied medical colleges. So I'm not promoting or doing anything for Praxilabs, but Praxilabs help us to provide science learning and science experience for our students, or for the most of our students. Almost 75% or more than 80% of our students came from colleges like science and like science. But the medical students and a College of Applied Medical Sciences, we have only like 10 or 15% of our students who, so we have specific audience for these specific requirements. But for the general needs, Praxilabs help us with College of Science and some other courses. If you're considering Praxilabs, I believe, Dr. Khadija, you will work with every single client like the way that you work with us to, let's say, increase their scopes, to improve their experience with the Praxilabs and bring more rich experience for their students. And I'm still here at University of Jeddah looking forward to more collaborate with you and enrich our student experience, inshallah, in the next year.
Thank you so much, Dr. Talal. Actually mentioned a couple of the things that we always talk in with our customers and with the audience, and whenever we have a chance to tell people that. So one of the most important things Dr. Talal mentioned was the gender inequality. So of course about females and males, and it's known in the region, not in MENA only, but of course again in Africa especially, it's a huge issue. But also he talked about the infrastructure, for example. If people are not ready with the labs or the computers, so you need a place, you need an online platform that is always there that you can access. But another thing also you mentioned, Doctor, which is having the equality, regardless the gender, having equal opportunity. So whether you are in a faculty or a university that can afford having this huge lab with the equipment, hundreds of thousands of dollars, or you are in a rural area where you cannot really have the resources, but you have competent students that would be amazing in STEM education, you don't want to not to give them this chance, really. So this is part of what we are actually not part, but it's the main thing and our vision in working here, in doing what we are doing. And of course, we are adding experiments literally every single month. So since Dr. Talal, they collaborated with us, as he said, we had 100 experiments. Today we have over 112 and continuously increasing. So we'll definitely love to hear from everyone here in the attendees if they require specific experiments. And I will quickly give just like a couple of minutes, show you here some slides I was preparing, and then Dr. Hiba will be giving the demo directly after me. Okay, just a second, just sharing my screen. Okay, so I just wanted to quickly tell you that, again, conclude by having the four important or the most important challenges we've been working on with University of Jeddah and other universities, which were mainly number one, and we always focus on number one, it's the limited access. Your students will not be able to enter the lab, even if you have the amazing lab and the big lab. How many times they can enter that lab, and how many times can they do the same experiment and repeat it to understand the concept? We don't get the concept, especially in experiment and in hands-on, from the first time. So how many times can the student repeat this in a lab with the cost, with the time constraint, and with a lot of his colleagues waiting for him to finish? So that's the most important thing we focus on. And then definitely number two, which is the safety of our students. We've been talking to a lot of professors, and some of them actually said it, like, we remove these curriculums or these experiments from our curriculum just because we cannot do it in the real lab. One of the most requested experiments I know from Dr. Hiba is the gel electrophoresis, and that's because it contains at least 3 different hazards, which are cancerous substance, ultraviolet radiation, and also a boiling liquid. So in order to really make sure that the students can still experiment and do this practice as much as needed, they can go into the virtual lab, they can do it once and twice and even 20 times till they are mastering it. And then at the very end, yes, maybe you can take them to the real lab, but only once, and they will not waste the chemicals. They are not going to do any safety hazards for themselves because they already know the lab and know how it works and know everything. So that's one of the also very important things for virtual labs. And finally, we come to the high costs, which is something we cannot ignore even in the advanced countries. I've been to the UK and Norway, and they are from the top places in advancement and in EdTech, but still, again, some of the labs can be above the budget that a university or a school can put, and that's why they might, again, remove it completely from the curriculum or just let the students watch a video. And that's, again, not the thing that we want. We want to improve our STEM education, and we want to improve our students' learning outcomes. So that was quickly the limitations, and I will skip the demo because Dr. Hiba will do it and show you. And very quickly, Dr. Talal was actually saying that he will do this measures with his students. But before we do it with our clients, a lot of studies have already been doing that, especially in the UK, in Queen Mary University, in UCL, and a lot of universities who focus on how the virtual labs can complement the real labs and improve the students' learning outcomes. And all of them were reporting the same numbers, that 60% increase have been seen in the students' performance after they do the semester with virtual labs and real labs, and also 80% increasing in the student retention, because we don't want our students to drop out and then we will not find STEM graduates. So these are the two measures that we really care about, which are the performance and the retention. And quickly, some of the feedback that we've been getting from the students themselves. They are exactly what we've been talking about, me and Dr. Talal, and then Dr. Hiba will be saying this as well, which is they were liking that they can repeat the experiment, they can access it from anywhere they are. They said they are more comfortable and confident. We cannot forget about the students who are, for example, having disabilities, or even just not disabilities, but they have some difficulties in their learning and they are shy, or they are not processing enough as their colleagues. So all of this, again, is better in the virtual labs than in the real labs when they are in front of everyone. And some of the things also we were mentioning, and it's very crucial in the physics experiments especially, is that when you get to change a liquid, for example, quickly, or something in the variables, you can do that in a virtual lab quickly, and you can do it in Praxilabs. You can change the variable, you can see the results immediately, as opposed to the real lab. How can you do that? It needs more effort, it needs more time, and of course it needs all these liquids to be available directly with you. So these are the most important comments we've been getting from our students, and we really believe that they are the same ones we've been focusing on. And yes, one of the things we've been really proud to have, which is working last thing with the Ministry of Liberia to avail our experiments to all the universities. So again, seeing our value not only in the advanced countries, we love to work with the European universities and the top universities in the US, but again, we want to do something for our region. So dealing with the UAE Ministry of Education or partnering with the Ministry of Education in Liberia is something we are proud of, and we are proud to get more of this work to the region to enhance our education. And finally, this is a quick thing, or a quick a quick slide about our partners so far, and we've been working more in the region here in MEA, and also again in Europe and the US. We'll love to hear from you all, and of course get the same experience to you all. Dr. Hiba, I don't want to take more of your time, and I want you to start the demonstration so that the audience can see by themselves.
Thank you, Dr. Khadija. Thank you, Dr. Talal. Thank you, everyone, for attending. I'm going to share my screen now to show you the virtual lab. I want to take you in a tour in the lab. I want you to see all the options that users can use to improve their learning outcomes. So I'm going to show you some of the experiments we've got, and I'm going to show you how to use the lab. So this experiment is for gel.
Yes. Just sometimes your voice is a bit low, so if you can just check the mic or something, or maybe change your the place of the mic. I'm not sure the reason, but sometimes it's a bit low. Can you try again?
Okay, can you hear me? Can you hear me now? Is it better? Still the same problem?
Well, see, sometimes it's just a bit low, but try to raise your voice, and I think we'll be able. If the attendee said that it's low, I will tell you.
Okay, so this is an experiment for gel electrophoresis of DNA fragments. The student is supposed to know how to make the gel by weighing the gel powder, adding a buffer, and then heating gel in the microwave. And then he's supposed to use the gel in a way, in the proper way, so that he can apply his samples into the gel. So right here in the lab, let me first show you the options. Right here we have this. We have the hints. We tell the students everything they need to do, all the steps, detailed steps that they need to take care of right here in this like robot thing. And you can remove these hints if you need to. Right here on the upper top left part, it takes you to the blackboard. In the blackboard, we have a PDF document that contains all the information that you need to know about the experiment. It contains the lab setup, it contains the learning outcomes, an overview of the principle of the experiment. It contains all the things that you're going to use in the lab, whether they are reagents or chemicals or labware or devices. Over here, we have an animated guide. It's a 1 to 2 minute video that shows you all the steps of the experiment so that you can know beforehand what you're going to do. Right here, you can control the language. Right, for now, we have an English language and Arabic language. You can control the sound and the hints. You can allow hints to be shown or not. This document is called the enrichment. It enriches your data about the experiment, and it tells you maybe some historical notes about the experiment, how it was first discovered, and so on. And over here, we have an exercise. These are multiple choice questions that the students can answer after the experiment. If they can choose any answer, and shows them the right or the wrong answer. And this button right here is to reload the experiment from the beginning. So to reload the experiment, I'll just click on it. We have instructions for how to use the mouse. The left click is to interact. The right click is to rotate around the lab, and you can zoom in and out in the lab. Okay, so this is like an overview what we're going to do right now. This is the lab setup for gel electrophoresis. As I said, you can zoom out and you can zoom in using these buttons on the right or the right click of the mouse. You can rotate around the lab, see all around the lab. Of course, everything is designed in the same way as the real lab. We take care of details usually. So right now I'm going to use the scale. We teach students how to use everything properly. There are some precautions when they use anything, like they need to learn that they need to tare the scale before weighing anything in it. So that's what we do. We add the thing that we're going to measure the powder in. Then we tare the scale. When it shows 0, I can then add the powder using a spatula. Now I'm going to take the spatula on top of the scale to release the powder. And this is the exact weight that I need. So I'm going to stop here, take the jar out, and then close the scale again. It's important to shut everything after you use it in the lab. So that's something we teach the students. We open the bottle, we add the buffer. Of course, we tell them how much buffer they need to add in case they don't know. And then we take the container, shut down the bottle. Now we need to use the microwave oven. Of course, we tell them some safety tip that they need to take care of. They need to cover this the cylinder that contains the gel to be formed, and they need to keep the cap loosely attached so that it does not blow up in the microwave. And when they take it out, they need to take care if it's hot or something. All of this is written for them to be able to take care of that in the real lab. Now let's move on to another experiment. This experiment teaches students about cell culture technique. So they need to understand that they need to keep the environment in which they will be working in sterile. That's why they use the ethanol to sterilize the hood that they will be working on. And then they use this to wipe the hood in one direction. This moves us to the next screen when they bring everything inside the hood after sterilizing it. Now we need to remove the vial that we have stored from the nitrogen, the frozen, the liquid nitrogen. We took the rack out, it has the vial. Okay, we're going to put it in the water bath to thaw it. It's supposed to be put in the water bath for about 50 seconds. So we need to turn the water bath on into the required temperature, which is 37. Now they learn to set the devices that they will be using. So this water bath, you need to set the time and the temperature. We need the time to be 50 seconds. And we need to set the temperature to 37. If I put wrong settings, it tells me to check the device settings. This is 50 seconds, temperature 37. In some experiments, long experiments, we got like milestones for the experiment to be done. So we have this option right here that you can move from one part to another. If maybe I went from A to B and I need to repeat B again without starting all over, I can click on B so that I start from B. This experiment is on bioenergetics. It tells the students, first of all, how to set up the device. This is the first part, and the second part is how to use the device and add the sample in it, and then add different modulators, and then check the oxygen level, the change in oxygen level based on what you add. So in the first part, they learned how to assemble the device. Now in the second part, they are supposed to add the sample. So before adding the sample, they learn that they need to mix the sample properly by pipetting in and out so that they have a homogeneous sample to use. Now they need to add the sample using a syringe. Okay, so I'm going to add the amount. I need to use 25 microliters using this syringe. As you can see, the liquid, the green liquid is now in the syringe. And we're going to put it where you're supposed to inject the sample. Right here inside the device, the green sample is within. I need to shut this tube. And right here, you can see that oxygen was consumed due to addition of the sample. It moved from 100 to 95 and so on. We're going to add all the modulators and see the changes. And then in step 3, students can see the graph that of the oxygen readings, because there is a graph that is a graph and an Excel sheet that is created of the numbers. Different numbers change after the modulators are added. So they get the Excel sheet from which they can work on and turn an assignment to their mentor. And the last experiment I wanted to show you is this. This is done when during cloning, when we need to calculate the transformation efficiency. We have many experiments that require calculations. So this is the main equation that students are supposed to use. These are the plates that they're supposed to count colonies of bacteria from. So they enter here the numbers that they see. And if they tell the wrong answer, tells them this is the wrong answer. Right here, there's a loan of bacteria. So I'll choose loan of bacteria, and then it will move and zoom in on the second plate. Second plate, I'm going to submit my answer. Okay, third plate, I have only blue colonies, so white colonies 0, blue colonies not gonna count right now. 125, correct? Okay. Wrong answer. It tells you the right answer. Submit. And this is the last plate. Now I'm going to submit my answers. And I'm going to calculate the transformation efficiency based on this plate. So we tell them how to calculate, how to walk through the equations that they need to use. Okay, so right now we have 0.5 nanogram and 50 microgram, which gives me 0.01 nanogram per microgram. This was calculated by the system. So I'm going to add this number right here. And I used 10 microliters, so I'm going to add the number here to get the final concentration. This concentration is to be added right here in the equation. And the number of colonies, 125, are to be added right there. So now I got the correct answer. I solved my equation. We also tell them that the experiment has been completed so that they know. And of course, they can repeat by reloading the experiment once again. So for now, I think I've shown you everything, all the options that users can use in the lab. And I'll be glad to receive any questions.
Thanks, Doctor. We'll get to the questions now. So if Dr. Talal is still with us, and
okay.
Of course, I will read the questions and see whether it's for our team or for Dr. Talal. So so one of the questions, Doctor, is I want to know if we can make anatomy experiment with our students. Do you want to answer this one?
Okay, all the experiments, any experiment that we can do, it needs to have a protocol. So it depends on what experiments can be done in anatomy. If there are variables that the students can see, if there is a protocol for anything, it can be done, of course. So, yeah. If there is an example, maybe.
Exactly, I was going to say the same thing. If you want to send us an example or just get in touch with us and give us we usually ask if someone wants to add an extra experiment, we ask them and we definitely get the content. We give it to our subject matter experts like Dr. Villa and the rest of the team in the different branches, and then we can get back to you and tell you, yes, we can do that and how long it will take us, etc. So please get in touch with us about this one. With the target group for this platform, can the teacher use it for middle school students? So for now, our experiments, we have, as I said, we have more than 112 experiments so far. It's actually a diversity. So some of them are matching year 1 and year 2 in Faculty of Science, Medicine, Pharmacy, Education, a lot of engineering. And what we've been seeing after that is that schools in the grades 8 to 12 especially are talking to us again and also taking our experiments. So as I said, the Ministry of Education, the UAE, is now working and doing the experiments for grades 8 to 12. We also have some of the STEM schools in the US using our biology curriculum, all of it. So it really depends on your school, on your students, on your advancement in STEM as well. So we can send you the portfolio. You can check it on our website and see which experiments can go with your curriculum. My question is, okay, so someone is asking about our support for STEM schools. So again, that would be the same answer exactly. We do not really work with someone specific. STEM schools like a university, like other schools, we give you our portfolio, we ask you to check it. And if you have any specific criteria or curriculum, for example, and you want to do it, just talk to us and we'll see how to collaborate together on that. Okay. Doctor, there is a question, but I'm not sure that I know the answer because it's totally scientific. So I'm not sure that I understand the word, but it says, does your virtual lab software cover scenarios of working with pathogens? Is it pronounced like that?
Pathogen?
Yeah.
Pathogens?
Yeah.
The
The microbiology, like microbiology experiments. If that's your question, yes, we have microbiology experiments in the QE. We're actually developing them right now.
Thank you, Doctor.
I'm looking for the question.
Yeah, I said that we'll answer it live. So if it's microbiology, as Dr. Heba said, we have our team working on actually a roadmap of more than 10 in the next period, and we'll be adding them continuously over the next few months. So just always check our website for the new experiments. Doctor, there is a question that says, can this lab handle issues related with germination and ecology?
We don't have experiments for now for this part, but it could be planned, as I said.
Okay, thank you, Doctor. How can you access this virtual lab? So there are two ways. You can go on the website, you can create a free account. It will actually give you 6 experiments in the different branches. You can go ahead, you can play with it, you can even give it to the students. They can try it. So you can try everything from the free account, or you can get in touch with us if you want to purchase or like subscribe for your students, whether you are an institution or even a professor. As an individual professor, you can definitely get it from us. So just send us an email, or on the chat on Facebook, we will reply directly. Chemical engineering. So Dr. Heba, what the experiments we have in chemistry and physics, someone is asking about if we have experiments for chemical engineering. So I would suppose these are the ones we have in chemistry, and in physics they can check it as well, right? I know that you are our biology expert.
Yeah. Yeah, I'm not sure. I think, yeah, I mean, we may find some like basics in the chemistry and physics lab. Yeah.
I'm answering on behalf of our chemistry and physics professors. So please check the experiment, because we have almost more than 70 experiments across chemistry and physics. So there might be ones that intersecting with your curriculum indeed. Specific experiences for each college. So someone is asking, or giving us a suggestion that we talk to each university, and if we are able to work with them on specific experiments. As I said, we definitely do that. We already did it actually just last semester with KPU from Canada. We did it with Glasgow from the UK, and we did it with Cairo University here as well. So when they needed some experiments that we did not have, and they actually had a very tight time, and Dr. Heba was the one responsible for our biology experiment for Glasgow and KPU. She had the exact names from them. For example, we prepare the content, we get back to them, we do the quality assurance and everything. When everything is approved from their side, we do the development and we give it to them. So we do not have a problem in customizing and in doing more experiments together with specific universities. There is no problem in that. Doctor, can we do any radioactivity related experiment? That is the question. I'm not sure of the answer.
Yes, we can, and they will be perfectly safe because they are virtual. So any experiment with steps 1, 2, 3, up to whatever number of steps there are, whatever hazards there are in the real lab, you can do it in virtual lab with 0% safety hazards.
Amazing. Tim is asking about our experiments in physics and actually modern physics. Yes, Tim, this is one of the projects that we're just talking about. We did it with the nanotechnology faculty here in Cairo University, and we created, as far as I remember, more than 20 experiments. Some of them were toxicology and some were advanced physics, but we have got in our portfolio, so please check the website. We had ones in optics, as you're writing, in optics. We had, I remember, yes, more than, I think, 10 in this area. So just please check our website. You will find the modern physics category there. Someone is asking if we support the VR glasses. I will not say unfortunately, because it's actually fortunately we are not keen on using VR for now, Muhammad. One of the reasons is there are a lot of debates till now on the use of the goggles in education. It can be used in games, of course, but in a lot of education platforms, it's not really the best practice to use it, because It sometimes causes dizziness to the students. It's not the best thing in education. And to be, for example, doing 30 minutes of an experiment using the goggles, this is one reason. But the other reason as well is we said we really want to improve education in different areas in the world. So we don't want to put a blocker like you need to get this with a specific cost, or this hardware, you need to have it, otherwise you'll not be able to work. And that's why our preference was to use only simulation software, which is just have a browser and you would be able to use it. So for now, we are not doing that. And maybe in the future, we'll be looking at AR instead. Doctor, do you have experiments for pharmacology labs? Doctor, there are someone asking about pharmacology.
We have some experiments that may validate for pharmacology, but we don't have a lot of them. Like, for example, the bioenergetics experiment I was just showing, we use different modulators, different drugs on the mitochondria to see their usage of oxygen. So this can be considered like a pharmacology experiment, but we don't have a complete list for all the pharmacology experiments that students do, whether in school or in the university.
Thank you, Doctor. There is also a question about integration with LMS. Definitely, as Dr. Talal mentioned, all our universities now work with us through the LMS system. And because we did it in a kind of a standard way, which is LTI, if anyone knows integration, technically it's done through a standard known globally. So we can integrate with any learning management system that does the same standard, which is Moodle, Blackboard, Canvas, Desire to Learn, any of the big, really known learning management systems. We integrated already with them, and our universities are working through them. And you said in terms of assessment, yes, definitely. The professor can say that this is a graded content, and when the student does the experiment and also answers the assessment questions that Dr. Hiba was showing, the grade will be returned back to the learning management system. So hope that answers your question. Someone is saying that the virtual experiments, the doctor needs preparation first from the teacher and then teach the students how to do it. So you've seen our students in the different universities. You can talk about this.
Actually, students are doing pretty well with virtual labs on their own. They have almost everything they need to know inside the lab. They have all the documents, they have all the preparatory messages that we need to send them, even an overview, an explanation of the theory, of the idea of everything. And they're very good with computers, unlike older teachers. So they are very good, and it's very user-friendly. That's what I've seen with students. So if the experiment falls within your curriculum and you already know the experiment with the main ideas, even if the steps are a little bit different, I don't think you need to prepare anything at all. You don't have to perform the steps in the lab for the students to see you performing. They can go on and start using the lab on their own, which will be much more fun for them than watching someone do it first and then they do it. أنا ممكن يعني أوضح الحتة دي كمان بالعربي أكتر، إنه الطالب مكتوب قدامه كل المعلومات اللي هو محتاج يعرفها، سواء كانت الفكرة النظرية اللي بسببها عملنا التجربة دي، إيه اللي أنت محتاج إن أنت تعرفه عشان تبتدي، إيه الأدوات اللي أنت محتاجها، الأجهزة اللي أنت محتاجها، الخطوات إيه، خطوة 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 مكتوبة له بكل تفصيل. وبالتالي لا، هو مش بصراحة هو ممكن يمشي فيها لوحده حتى من غير أي تيوتر معاه. لكن التيوتر لو هيحب ان هو يدي مقدمه الاول او يفهمه انت هتعمل كذا 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 في التجربه، مش مضطر ان هو يشتغل على التجربه بايده، لانه ممكن تكون ممتعه اكتر للطالب ان هو يشتغلها بايده على طول دايركتلي من غير ما يتفرج على الحد الاول، هتبقى بتاخد منه شويه وقت. يعني ما حسيتش ان انا في ولا مره شرحت للطلبه باستخدام الفيرتشوال لاب ان انا محتاجه اشتغل التجربه قدامهم بايدي الاول.
Thank you, Hiba. You said that there are more than 100 trials. Are they available for free? Because so actually the one that is free, we said the free account gives experiment. When you need some more experiments, it's for a subscription. It's very affordable amount, and you can check on the website. You'll find 3 different plans. One that gives you 8 experiments, 20 experiments, or 50. So according to what you need, and it's actually also different duration. So you don't have to take the whole year. You can take a month or a semester or a year. So just depends on your needs. Okay. Support. Do we support nanotechnology Yes, as I said, we had worked with the nanotechnology and we've done more than 20, 23, 25, around this much experiments for them. So please just check our portfolio and you will find the experiment that you need. If you want something different, please send to us and we will definitely get back to you. Doctor, what about dissection experiments? This is another question.
We don't have dissection experiments for now, but they can be performed using our lab.
Okay, thank you. There's an interesting question which we usually get, and it's technically a challenge, so I will just mention quickly. So someone is asking, is it a one by one, or there's a feature for group experiments? Yes, for now it's one student who can do it at the same time. And we know that sometimes in the real lab, students do it together, but actually one of the reasons we're doing virtual labs is to give the student his own environment to practice as much as needed. But if we are talking about teamwork and things like that, yes, we're looking at this entire roadmap to see how we can do like a network and allow the students to work together, or even allow the professor to see what the students are currently doing. Thank you for the question. And another question is, sorry, just the thermochemistry. Did we answer this question, doctor? Do we have thermochemistry experiments? I'm not sure.
I'm not quite sure, to be honest. I don't know all of the chemistry experiments portfolio. So maybe we can send them the portfolios to check the experiments they require.
Yes, please, Islam, please get in touch with us and send you the portfolio and you can check it, or just send us on Facebook or the website so that we can get your question to our chemistry experts and get back to you. Doctor, this is a question for yourself, please. If STEM is totally practical, how could we implement it in different subjects in the virtual lab? So someone is asking, if it's really practical, how can they implement it in different subjects? I mean, from our experience, what have you seen that we were already able to implement in our virtual labs?
I'm sorry, I think I don't understand the question fully. It could be implemented in all subjects.
I think he's saying that because STEM is totally practical, he thinks that it needs to be done really in the real lab only. So how are we doing it in the virtual lab? I think that's the question as far as I understood it.
Okay, so as we said, virtual lab, it shouldn't be used only totally to teach students. It could be used as a preparatory step, as we said, by telling the students about the theories that they're going to implement, by telling the students about the safety precautions they need to know, by telling the students on the correct procedure step by step to be done. They can repeat this over and over, so that when they actually go into a real lab and perform all the steps, they can do it with self-confidence because they've tried it before. They can do it with much more retention of the data that they're supposed to learn. So I think virtual lab has an important role, really.
Thank you, Doctor. Okay, I think I'm answering most of the question, but we still got 2 or 3. So someone is asking how, I think they want to know, okay, transfer, how to make the virtual lab creative and effective, not just animation or videos. So I think what was, sure, go ahead.
How this can be done by changing the variables used. Like, for example, in physics experiments, this has been done in a lot of physics experiments and in some biology experiments. If you change the variable and students don't know what they'll get in the end, if the results of the experiment is, for example, a graph or an Excel sheet with different numbers that are random, this makes it more effective, it makes it more creative, and it makes students think and not just see just a result they expected to see. Some results are in the form of images, so they can receive different images and interpret these images to be able to get different outcomes. Also, it's not comparable to videos at all, because students actually, even if the experiment does not show different results, students are able to implement steps step by step on their own, and they see messages that tells them why you're doing this step, why you're adding this reagent, why you're moving this from here to there, why you have to do whatever you have to do before the step. So it's not like a video that you sit back and watch, and it's not, you're not learning in a negative way, you're learning in a positive way because you're participating. Someone is asking you, Khadija, in the chat box about students learning at home, being able to use the lab at their homes. So I think you should answer that.
Yeah, sure. I was just checking that we have 3 questions left. Yes. So definitely, this is exactly what is being done. So someone is asking whether university can pay for the experiments and then the students use it from home. So this is exactly what happens now. Any university or school that wants to let the students use Praxilabs, they talk to us, they purchase the experiments from us, and then we give the students, whether we give them usernames and passwords to log in from the website, or if you have a learning management system, as we said, we integrate directly with the learning management system, so all your students can go from there and see the experiments. And of course, it will be from home. It will be from anywhere. They don't have to be home, even in the vacation, in the university, at home. It doesn't really matter. They need the website or the web browser basically, and they need to enter, and that's it. So yes, definitely we can do that. I think
animal experiments.
One of the last animal, yes.
I think we have one. We don't have a lot of experiments specifically on animals. We have one experiment maybe, but the biology experiments in general they have all the same principles. Like for example, if like DNA extraction, like gel electrophoresis, protein electrophoresis, HPLC, all of these experiments, they can be done in all sorts of biology, whether the sample is from animals or from plants or from humans or from culture cells or anything. But we have, I think, an experiment about horses, something, we use ultrasound on horse leg to see, I think, the anatomy. So we can do more of that if needed.
Thank you. I'm just checking quickly because some people are sending the question in the chat box, so I will check quickly if you have more questions here. Do you cater for specific GCSE required practicals? So Hissam, our reply to this, as I said, in general, we are catering for different curriculums. So we have STEM schools working with us. We have other normal schools who have IG curriculum or IB or even American. So we don't really cater for a specific curriculum or for a specific school program. So what we do is we send you the portfolio. You can even get it from the website, of course. You do the mapping. We already do it, and we know that we have more than 50% intersection with the GSE curriculum, but you can check it yourself. And then when you choose the experiments that are common for your students, you can just ask us to have these experiments, and that's all. So I think just going quickly through the chat. Thank you. So I think the last question, one of the things is...
One last thing?
Yeah, sure.
Go ahead, yeah.
I was just saying that one of
Go
the
ahead.
things they want to see that they can experiment themselves. So definitely, Hanan, you can practice yourself. I mean, you can do both ways. You can get a free account if you don't want to subscribe, of course. You can get a free account and use the 6 experiments to practice yourself, or you can subscribe if you need specific chosen experiments from our portfolio, and you can just use it with your students even. So, Doctor.
Okay, so in the chat box, someone is asking, virtual experiments can replace the real experiments, and can virtual experiment have the same results and attain the same objective learning as real laboratory? For the second part of the question, yes, virtual labs have the same results. We show results to users that they can use to interpret and understand what has been done in the experiment, and they have the same objective learning, of course. In my point of view, a virtual lab to replace the real lab, it depends. It depends on my learning objective. Is my learning objective, am I only teaching students on different theories and how to do things, because I want them to learn about the theories, and they're not going to, in their career later on, they're not going to use their actual hands to, in a laboratory, to perform the steps, then virtual lab can definitely replace the real lab. And one positive thing about virtual labs is it's not, if students are not interested in lab work, and they're not going to work with their hands later on in their careers, then virtual lab will save them the time. And sometimes students feel bored, because in real lab you can perform an experiment on several days to see the result, maybe several weeks to see the results. But in virtual lab you can perform a very long and lengthy experiment in only 1 hour, and see the results right in front of you, and you can interpret the results and understand why you've done all the steps that you've done. You won't lose your interest in the experiments, because you will be connected. It will all be connected together in lengthy experiments. So that's what I wanted to answer. There is a question if a user can create a step.
I will answer this, but if you can answer first the question about the bioinformatics or next generation of sequencing. Someone is asking about specific experiments.
We have next generation sequencing. We have an experiment for DNA sequencing using NGS, but we don't have the bioinformatics tool in the experiment. It's not within the experiment, and it's not on its own.
Okay, thank you, Doctor.
That's it.
The last question I think now is 10, which is هل يمكن للطالب ابتكار أو إضافة خطوة أو مرحلة غير مجهزة? So quickly, it's asking if we can add or add another specific step to the experiment, do something that is not in the term, as far as I understood the question. So for now, what we do is we do the same experiment steps and procedure that the students are they need to learn in the real lab. So for example, again, as I always say, it depends on the learning objectives. So for example, some titration experiments we have, if the doctors tell us that the students can do like mistakes and drop several, for example, change the amount of drops, and then the color will be changed, we allow them to do that. So it's okay, because the learning objective says that. But for instance, Dr. 𝙎𝙘𝙀 tells us that in the biology, in this specific experiment, the students in the real lab are not allowed to continue and do like all these mistakes, because they will get a contaminated sample, for example, at the very end, then we will not allow them. So it really depends, because we are trying to mimic the real lab, and we are trying to make students practice and make the best thing, or make the best use of the time. So we don't want them to do like all the mistakes and all what's popping in their mind, and then really get used to it and then go to the real lab and do the same mistakes. This is not what we are trying to do, but we are trying to let them practice the right experiment, the right steps, and of course the safety instruction that they need to take care of. Is it free to get this experiment concerning NGS? Is this one of the free experiments, Dr. 𝙎𝙀𝙀, or do we need to do they need to subscribe?
No.
It's okay. The NGS experiment, do they need to subscribe together?
I don't think it's free. I don't.
Okay.
I thought I was muted. Sorry. I don't think it's free.
I think
as far as I remember, it's not one of the free experiments.
Yeah, no problem. And that, yes, definitely you'll get the recording of this link. It will be sent to you. I don't want to take time from our audience. We've been really, really happy to have you all with us. I hope we answered all your questions. Thank you so much for your time, everyone. Thanks, Dr. 𝙎𝙀𝙀. Dr. Talal had to apologize and leave because he had another meeting he had to attend. So again, thank you so much for attending with us. Please get in touch if you want to ask about any experiments or anything we were not able to reply to you in this webinar. Send us on the Facebook Messenger or on the website, and we'll get back to you. Thanks, Dr. 𝙎𝙀𝙀, again, and an amazing demonstration as usual. Thank you, everyone. Have a good day. Thank you. Bye-bye.